In this video, we are going to talk about how to construct a polynomial using divided differences method. So we have a problem that the 3 points data in the form of xy is given, and we have to construct the polynomial using divided differences method. And after we construct the polynomial, we will have to find f of 5, the value of the function f at x equal to 5. So the first task here is to construct the polynomial by using the divided differences method. Since we have 3 points data and we know that if the data is 3 points x0, y0, x1, y1, x2, y2, the maximum degree of the polynomial, Newton's polynomial, will be 2. So we write P2 of x, and Newton's polynomial involves A's, polynomial coefficients, A0, A1, one linear factor, x minus x0. It's P2, you stop at A2, and two linear factors, x minus x0, x minus x1. Since we have to construct the polynomial by using divided differences method, so now we are going to write Newton's polynomial in divided difference form. So what we shall do is we write P2 of x, and in this polynomial on the right hand side of P2 of x, we will replace a's in the divided difference form, in the divided difference operator form. So we know that a0 in divided difference operator form is nothing but f of square bracket x0, which is actually equal to f of x0, and we know that f of x0 is also y0. A1 is f of square bracket x0 x1, and A2 is f of square bracket x0 x1 x2. So we will write P2 of x in divided difference form, which is A0 is f of square bracket x0, A1 is f of square bracket x0 x1 into x minus x0, A2 is f of square bracket x0 x1 x2 into x minus x0 into x minus x1. So now that we have written Newton's polynomial in divided difference form, we have to construct the divided difference table, and from table we will plug in the values in this polynomial. So let's construct divided difference table. So to construct the divided difference table, let's put in the x values, which are 1, 3, 7, and y values 2, minus 1, 4. Let's name this data x0, x1, x2, y0, y1, y2. So we know that y is written as f of x, but this could be written as f of square bracket x, which can also be written as f of square bracket 1 dot, meaning there is 1x. The next column that we are going to construct is f of square bracket 2 dots, means inside we will have 2x values. Let's construct the differences. The arrow between these two values, so the first value that we are going to get here will be named as f. Inside the square bracket, the starting two x's, it's a 2 x's column. So the starting two x's are x0, x1. The next value will be calculated here, and its notation is square bracket. From the previous term, we will drop x0 and then continue with x1 and the next value, which is x2. Now let's calculate f of x0, x1. Since it's the arrow between minus 1 and 2, so first the difference between these two values, minus 1, minus 2, second minus first value, divided by the difference between last x and the first x, means x1 minus x0. x1 is 3 and x0 is 1. So when we calculate this becomes minus 3 by 2. That's the value of f of x0, x1. Now let's calculate f of square bracket x1, x2. First, the arrow is in between -1 and 4. So you calculate 4 minus -1. Second value minus first value divided by the difference between the last x and the first x. Last x is x2 and the first x is x1. x2 minus x1, which are 7 minus 3. Let's calculate this. 4 plus 1, 5, divided by 7 minus 3, 4. So we have the third column values, f of x0, x1 and f of x1, x2. We can put an arrow between these two values and calculate the divided difference. But let's first name this term that we are going to get. So this is the fourth column, and now it will involve 3x values. So we are putting 3 dots, and the term that we are going to get here will be named as, since it's a 3x values column term, it would involve the first 3x values. The first 3x values are x0, x1, x2. Now let's calculate this term. So arrow is in between 5 by 4 and minus 3 by 2. So let's calculate this difference. 5 by 4 minus 3 by 2 divided by the difference between the last x and the first x, which is x2 minus x0. So x2 here is 7 minus x0 is 1. Let's simplify this term, which is 5 by 4 plus 3 by 2 divided by 6. Taking the LCM, we get 11 by 4 over 6, which is 11 by 24. So we have constructed the divided difference table and we have named the differences. Now let's plug in the values from this table into this polynomial P2 of x written in divided differences notation. So we have the polynomial P2 of x in divided difference form, which is f of square bracket x0 plus f of square bracket x0 x1 x minus x0 plus f of square bracket x0 x1 x2 into x minus x0 into x minus x1. Let's plug in the values. P2 of x, f of square bracket x0 is same as f of x0 and f of x0 is same as y0. So from this table the value of y0 is 2. The value of f of square bracket x0 x1 from the table is this f2 dot columns, the first value, which is minus 3 by 2. X minus x0 is 1 from the table plus f of square bracket x0 x1 x2. In the fourth column, the first value, the only value is f of x0 x1 x2, which is 11 by 24. So we will put 11 by 24 here. Into x minus x0 is 1 into x minus x1 is 3. So this is the Newton's polynomial in divided difference form, where we have plugged in the differences from the divided differences table. So the polynomial here is P2 of x. It is also the function f of x, and f of x is also written as y. So once we have constructed the polynomial, let's go back and look at our question. Our job was to construct the polynomial by using the divided differences method. So we have done that. We constructed the polynomial by using the divided difference table. After constructing the divided difference table, we picked the differences and plugged in the Newton's polynomial in divided difference form. Now that we have the polynomial constructed using divided differences method, we have to find f of 5. We know that P2 of x is same as the function, which is same as y. So we have to find f of 5. Please know that this 5 is the value of x. So to find f of 5 in the polynomial, wherever there is x, you put x equal to 5. 2 minus 3 by 2. In the place of x, you put 5. 5 minus 1 plus 11 by 24. 5 minus 1, 5 minus 3 and just simplify. You have f of 5, 2 minus 3 by 2, 4, plus 11 by 24, 4 into 2. So after some simplification, we get f of 5 as minus 1 by 3. So we constructed the polynomial by using the divided differences method, and we had to find f of 5, which we have done by plugging 5 in the polynomial p2 of x. p2 of x is also written as f of x, which can also be written as y. So in the next video, we are going to construct the polynomial for the given data by using the forward differences method.